Hi everyone, this is Ms. Sahra, and this is the last video that will help you review for Term 2 exam for science. Okay, we've already gone over the structure of our exam. We have 15 multiple choice questions and 5 written response questions. This video is about Lesson 3, Impact of Energy Usage. There will be 2 questions from this lesson, one on page 129 and one question from page 132. The question from page 132 is going to be a written response question. Free response question means that you will have to write an answer. The other page, page 129, will be multiple choice question. So let's look at some impacts from using energy resources to produce electricity. When we produce electricity, sorry about that. When we produce electricity, a few things may happen. So impact, we are looking at what does it do to the environment around us. So over here in this picture, we can see that they are mining. They are mining to remove fossil fuels, which is coal. So they are mining coal, but any mining of fossil fuels will cause damage to the environment. It will cause animals to lose their home. So fossil fuels are coal, oil, and natural gas. And when we mine for these things, we cause a loss of habitat. That means animals lose their homes. So this is an impact of mining for fossil fuels. When we build dams to create hydroelectricity, so over here, sorry about that, over here we have a dam and it is being built to produce hydroelectricity. When we build this dam, we cause also a disruption. As you can see here, they had to clear a lot of land. So this also causes loss of habitat. It will also cause a problem for fish. If you think about what animal lives inside of water, it is a fish, right? So these little fish, they can't go back and forward because the dam is in the way. And some fish only lay their eggs in the same place every year. So now they have a problem. They can't go back to lay their eggs, and it will cause a problem for the fish. They don't know where to go. So it causes problem for fish. We call it migration when they move from one place to another to lay their eggs. Okay, so fish are the ones that are having a problem with hydroelectricity. We look at the last picture. I'm sure you can tell by now what has happened to these poor birds over here. So wind energy is produced by these big turbines, and this wind energy or wind power will cause a problem for birds. As birds fly into them, they can cause them to die. Okay, so this is an impact from using energy resources to produce electricity. Okay, you may read more about it on this page. You can pause it and go through it. There are 2 questions on the bottom of the page that may come through as well. For example, how does burning fossil fuels cause pollution? So as we burn fossil fuels, we end up with pollution in the air, so air pollution. And as we have this strip mining, we end up losing trees, plants, and soil. They are cleared away from here. Okay, so now let's look at our written response question. Over here, you may be given this here, and then they will ask you to answer the question. What are some ways people can conserve resources? So look at the pictures and then answer according to what you see in the picture. Over here, we can see that there is a light. So how can I save? Conservation means to save resources. So to use less. Okay, so one thing I can do is to turn off the light when I leave the room. So as discussed in our class, most of you said you can remember the word put off instead of turn off. So we will try and use the word put off. Okay, so put off the light when not using. So when you are not using it, if you put off the light, you will save energy. Same thing goes for this device. Put off computer when not using. Okay, so even if your English is not good, you can memorize put off. And then you just know, look at the picture to change the word, right? Over here we can see our shower. Okay, so this one is a little different because we are going to say take short showers. If you use a short shower, this is one of your words for English, so you should be knowing the spelling. Take short showers, you will save energy because less water is being used, so less water has to get heated up. Over here, we have a picture of a tap. And remember, we're not talking about saving water, we're talking about saving energy. So here we will say again, put off hot water when not using. Okay, because hot water is the one that uses energy to heat up. Over here we have a picture of a car. If we share our car, the word for sharing your car is called to carpool. If we carpool when we can, we will save energy. So if you cannot remember the word carpool, it means to share your car. Okay, so share your car ride when you can. Carpool means to drive together to the same place. The last one is showing you it's an olden day thermostat, the thing that we use to turn the AC up and down. Okay, so put off the AC when you are not using it. We all know the AC uses a lot of electricity. So when the weather is not too hot, like right now, we can turn off the AC, put off the AC when not using. So I hope you've realized that for most of these, if you you start your sentence with put off, say what's in the picture, and then end it with when not using. Please remember to write complete sentences. If they do not make sense, we cannot give you the mark, okay? So please go through them, turn them into sentences. There will probably be some lines here at the bottom of the page. You will have to complete your answers over there, okay? Okay, so here are the answers from the book. You may go through it. But again, I've shown you an easier way of learning it, right? Okay, another question you may be asked, because maybe they may ask you something completely different. They may ask you, what does conservation mean? We started off with saying conservation means to save and use resources wisely. And the last thing we may ask you is, what are the 3 R's? They are reduce, reuse, recycle. Okay, here's your last practice. Please go into it, give it a try, and good luck. Hi everyone, this is Ms. Zahra and we are reviewing for the end of Term 2 Science exam. In this video, we are going to be reviewing Module 2, Lesson 2, Renewable Energy Resources. There are 2 pages that will be in the exam and both are multiple choice questions. Okay. So remember there will be 4 marks each. Page 110 and 114. On page 110, the question will be about the picture. So this picture is showing biomass. Biomass is an alternative and renewable energy resource. Okay, in a previous video, we explained the difference between renewable and alternative. Alternative means making energy without using fossil fuels. So generating electricity. So electricity without using fossil fuels. And renewable means we can use again and again. Okay, so because we can grow trees over and over in a short amount of time, biomass is renewable. And because it is not a fossil fuel, we also can consider it an alternative energy resource. When we burn or these trees, the waste of trees to make energy, we will create pollution as well. So biomass does create pollution just like fossil fuels do, but it is renewable. Okay, so some questions you may get is, why is it renewable? What kind of energy is it? Can you give an example of it? Can you identify it in a question? What kind of energy do we get from plants? Things like that. So as long as you understand that trees, plants give us biomass energy, we can use it to turn it into biofuel, which is a replacement for petrol, which is made from fossil fuels. So this is the main information you need to have, okay? So we can replace this in a short amount of time. That's why it is a renewable resource. Okay, so make sure you understand those 2 words, the meaning of it, and the meaning of biomass and biofuel. On page 114, there are 2 pictures on this page. So the question could be about this wind turbine, or it could be about the table. Okay, so if we look at the wind turbine changes the moving energy of wind. So it changes moving energy to electrical energy. Okay, so this is an important point. It is a renewable resource. So please make sure that you know that it's converting moving energy into electrical energy. The other kind of question you may get is about reading the information from this graph. We've already gone over how to use the graph and the key over here, so I think this one should be a little easier. Okay, if you want, you may pause this video and see if you can answer the questions on the side, and then unpause it and see if you got it wrong. Okay. Percentage of energy is produced by biomass. They can ask you any of these. Right, so let's do biomass as an example. So I'm going to look for this word over here on the side, and I found it here. So now I look for this color inside of my chart. It is this color over here. That is percentage. So my answer is 11%. Question 2. What is the most widely used renewable resource? The most. If I look at my number, the biggest number is hydropower. Question 3, what is the least used renewable resource? So least would be the smallest number that I have, and that is solar. How much electricity is produced from, for example, they give you two together. Okay, this is unlikely that they will give this to you. In case they do, if they give you two of them, you need to add the numbers together. So let's look at wind and hydropower. So wind and hydropower will be 32 plus 52, and our answer is 84. Yeah, I prepared some practice questions for you. Please give them a try. Hi everyone, this is Miss Sahra. We are reviewing for the end of Term 2 Science exam. And in this video, we are looking at Lesson 4, Heat. The pages that will come in the exam are page 69, 70, 71, and 74. This page over here, page 70, will have a free response question. That means writing. The other pages will have multiple choice questions. You can see in red that I have circled pictures because on this page the question will be about the picture, and on this page they have told us also it will be about the figure, but I'm not sure which picture it will be about. So you must understand how to answer questions about all of them. Okay, so we will start with page 69. If we look at these two blocks, right, this block has a high temperature. That means that it is warmer or hotter, right? So we can say this one has a higher temperature and this one has a lower temperature. Heat is the movement of thermal energy. Okay, so the word heat means the movement or transfer of thermal energy. And that energy moves from the hot object to the cold object until they are the same temperature. When they are the same temperature, it will stop moving. Okay, so the key concept you need to remember is that energy will always flow from the warmer object to the cooler object. So from the warmer to the cooler object until they are the same temperature. And the one with the higher temperature has more energy. Now let's look at the three ways this happens. We call this heat transfer. Heat can transfer when two things are touching each other, like in the first picture. We call this conduction. They can also travel as fluids like water, which is your liquid, or air, which is a gas. The hot air at the bottom, the particles get hot, they rise up. At the top, the cooler ones are pushed down, and it continues in this circular shape. Okay, so at the bottom here, imagine that there is a V as it goes up and down. And the reason for that is because conduction and vection look almost the same. But this one that is touching has a D, and the one that is going up and down has a V. Okay, so please remember the difference. Okay, so this one travels in a circular motion, like a circle shape. This one is touching. And then there are days when heat transfers through empty space as a wave. And this happens in radiation. like when the sun's energy comes through space, radiation. Okay, so they may ask you these three questions. They may also ask you what type of energy is transferred. Remember, that is thermal energy. Heat transfers thermal energy. Now we're going to talk about the speed that it transfers at. So radiation, because it is moving through empty space, is very fast. It is the fastest by radiation because it travels through empty space. Convection travels in liquids and gases, so it is also fast. And conduction is the slowest that heat travels, and that is because it needs to go through every single particle as they have to touch each other for the ends to get hot. So it takes a lot of time for this to happen. If the particles are close, you see that it heats up faster. But if I had to move them away from each other, it would take time for this one to touch this one and then to touch the next one and transfer the energy. So by conduction, heat transfer is fastest in solids when they are close together. It is slower in a liquid, and it is the slowest in a gas. And this is important for us because it introduces the topic of thermal conductivity. So thermal conductivity is how good a material is at transferring heat. Ability means how good it is or how bad. How good or bad a material is at transferring heat. We already said that solids are very good, and then liquids, and last gas. So why is this important? Because sometimes we want materials to get hot, and we want them, we call these conductors. They allow the heat to move through quickly. Just like with electricity, we also had conductor. Conductor means the same thing for both. So thermal conductors allow heat to move through quickly, and thermal insulators do not allow the heat to move through. So they stop the movement of the heat, right? They don't let it through. So why is this important? If we look at the materials we have here, people use these different things like jackets to keep ourselves warm. We wear a jacket when the air is very cold. And because thermal energy moves from hot to cold, it would move from your body, which is hot, to the air, which is cold, and you would become very cold. So this jacket stops the heat from moving, so your body stays warm. These objects over here, maybe you have noticed what they are: gold, iron, aluminium, copper, steel, and silver. They are all metals. Metals are excellent thermal conductors because they let the heat travel through them very quickly. So the whole piece of metal will become hot very quickly compared to the insulator. And you will see that is why we use most cooking utensils, things we use to cook with, we want it to get hot quickly. So most of them are made from metal. Okay, so over here you may also be given a question about this table. So when reading a table, you need to look for words that say most or least. Okay, so most, another word for most would be the best, or the least means the worst, the one that's not good. So most is your biggest number. So let's look at which one is the most in this picture. We can see silver is the most. That means it is the best conductor. And the one that is the worst, which is wood, will be the best insulator. Okay, so remember that it will be a multiple choice question. As long as you understand the concept, you should be able to answer it. On page 71, you will be asked questions about the picture. So again, like I said, I don't know which picture you will be given a question about, so you should understand every image. This picture is showing us how thermal energy is made by friction. Friction is when two objects rub together and they go in opposite directions. So friction between the match and the box causes thermal energy to be made. In the next two pictures, we may be asked about which bulb makes more light or which one makes more heat or uses more electricity. So the first bulb is called an incandescent bulb, and the second is our LED. The LED makes more light and doesn't waste as much energy. The other bulb uses more electricity. Incandescent uses more electricity because it makes less light and it wastes a lot of its energy as heat. Okay, now we're going to speak about our graph. So it is more likely that you may get this question in the exam, but again, you never know. So if you have to read a graph, look carefully at this. This is your key. In the key, you will know what to look for from the question, right? So there is heat. The heat is in black. That means 9 and 98 is the amount of heat that each bulb makes. And remember to look on the side. LED makes 9. Incandescent makes 98. Okay. Then we will look at light. Light is in yellow. LED makes 91. Incandescent makes only 2. From this, I can tell which one is better. So which bulb produces more light? Which one makes more of the yellow? It is the LED. Okay, if we were asked which bulb uses more electricity, its job is to make light, not heat. So if it is making a lot of heat, it will waste energy. It will use more electricity. So even though the question is not asked straightforward, you should understand that concept. If it's making more heat, it will use more electricity. And that would be our incandescent. Okay, maybe I may ask you how much, so the number. Okay, so for the number, you need to again look at our boxes, right? How much light is produced by each of them? So we're going to look at light and read your question carefully. The incandescent will be 2 and the LED will be 91. How much heat or light is produced by LED or incandescent? So now the question is reversed and we have heat we are looking at. So incandescent is 98 and LED is 9. Okay, please scan the code or join using this code over here and give this lesson some practice. Good luck. Hi everyone, this is Ms. Sahra. We are reviewing for the end of term exam for science. Okay, in this lesson we are going to be looking at, in this video, we are looking at Module 2, Lesson 1, Non-Renewable Energy Resources. From this lesson you will find 2 pages are coming in the exam. Page 95 will have a written question based on this picture, and page 97 will have a multiple choice question. So let's look at the pictures on page 95. Page 95 has 2 pictures. the one with the oil rig and the one with the process where coal is being converted into electrical energy. So possible questions you may get about this picture. You need to know what is being shown in the picture. This picture is showing how crude oil is removed from the ground. Okay, crude oil is a fossil fuel. Okay, so crude oil is being removed from the ground. Because we know it is a fossil fuel, we know it is non-renewable. We also know about other fossil fuels like coal and natural gas. And you need to know what makes a resource non-renewable. Remember, this will be writing questions, so they may ask you anything about what is being shown in the picture, so what's connected to it. So to define a non-renewable resource, it is a resource that will be finished before we can replace it. So used faster than it can be replaced. You cannot learn how to spell these words. You could learn, you could say we will finish it before we can replace, or we will finish too quickly. Too fast or quickly, okay? So find a different way of saying the same thing. Now let's look at the second picture. The second picture over here shows us how energy is being converted from coal, which is again a fossil fuel, and it's being burned, and that energy is then converted through many processes to electrical energy. So maybe they may ask you to circle the non-renewable energy resource. In that case, you must make a circle over here. Coal is our non-renewable energy resource. They will also probably take these words away. You will not find them in the exam. It will be blank. You need to understand exactly what is happening at every point in the diagram. So let's look at what's happening in the diagram, and then you can practice seeing if you can answer them on your own. Okay? 5.1, coal, this black stuff, has chemical energy inside of it. And that coal is then burned. And burning the coal changes its chemical energy into thermal energy. Remember, thermal is our heat energy. We then use that thermal energy to heat up water, which makes steam. You know, like from the kettle, when you make tea, the water that gets hot, it comes up. Well, as that water comes up, it's moving. And we use that movement to spin this thing over here. So this is called a turbine, and that turbine is connected to this generator. The generator machine that converts moving energy to electrical energy. So this generator is moving energy or kinetic energy into electrical energy. Okay, so this is what is happening in the picture. Possible questions they could ask, which kind of energy heats the water, what converts the energy into electrical energy. That would be a generator. So please learn the spelling of all the words. They could also ask you this. Like I said, they will take away the words in the box, leave it empty. They could tell you, label the energy transformations happening in the picture. So, number one, that we have chemical energy. At number two, chemical energy changes to thermal energy. At number three, the thermal energy changes to kinetic energy. If you cannot write the word mechanical, use the word kinetic, it's fine. At number four, the generator then changes the energy to electrical energy, the moving energy. You may state that it's kinetic or mechanical, whichever word you decide to put over here, okay? So you will notice if you learn the word once, you use it into the next box. You see that? and the extra word would be generator in the last box. Right, and it produces electrical energy. So if you can remember these words, you'll be okay, inshallah. Right, just practice it a few times. On page 97 of our book, we have a multiple choice question that will come. Okay, so the key concept on this page is that they mention the law of conservation of energy, which we learned about in term 1. We cannot make energy, we cannot destroy energy, but we can change it. So you need to read through this section and see all the different ways we can change energy in our daily lives. So let's think about one example of the car. If we have a car, think about what makes your car move. We put petrol into it. The energy inside of petrol, just like our coal, fossil fuels, is chemical energy. This chemical energy is then changed into moving energy to make your car move. Okay, so this is one energy conversion that is happening in everyday life. Another thing that happens in everyday life is if we think about a light, when we're putting a light on, or a campfire when you go camping, how are they the same? So if we think about them, they may start from different types of energy. A light bulb uses electrical energy to make light, and a campfire uses chemical energy. But both of them will make heat and light. So both of them turn a different energy, another form of energy, into heat and light. Okay, I have prepared some practice questions based on this lesson. Please give it a try. You may scan the code or enter this code into the quizzes link. Okay, good luck.
Hi everyone, this is Ms. Sahra, and we are reviewing for our end of term exam, term 2, and today we will be looking at lesson 3, electricity. In this lesson, you will get 3 questions from it. From page 48, you are going to get 2 multiple choice questions, and from page 50, you will get 1 written response question, so free response. Okay, so on page 48, these are these points that I've made, these questions are just the main points that you need to understand. So you can pause this video and try and find the information yourself and write it down. Okay, so what is electric current? Electric current is the flow of electric charge. So these little blue things, as they are moving, it is the flow of electric charge through a wire. So as these charges move through the wire, we call this electric current. The path that it's moving on, so from here all the way around to the other side, is what we call a circuit. So the circuit is the path, like a road. So the circuit is basically like a road or a path that the electricity travels on. If it is open, you will see that it breaks the circuit. So when it is open, it will cause the electric current to stop. So an open circuit will stop the flow of current. And this is how we can control it. We don't want electricity to just flow forever. Sometimes we want it to stop. And we use a switch to open the circuit so that we can stop it from moving. When it is closed, a closed circuit will allow the electricity to flow. Okay, so these are the main points about electric current, open circuit, and closed circuit. So again, electric current is the flow of electric charge through a circuit. The circuit is the path it's taking. And if it is open, it will stop moving. If it is closed, it will move. Okay, so now let's talk about when it will move and not move, right? So we said in the circuit, there are different parts. So a circuit is made up of this here is we know is a light, right? Our light. In the circuit, a light can be anything. We can put any device over here, which we call a resistor. A resistor is a device that takes out and transforms the energy. So the energy at this point will change into something else. So the thing that gives the energy to the circuit is our voltage source. In this case, our voltage source is our battery. So the battery is a voltage source that gives the initial energy, the chemical energy, into the circuit. So from here, it starts moving through the circuit and it becomes electric current. Okay, this blue line represents a wire. The wire is made of a material called a conductor. A conductor allows electricity to move through. If it if it's anything made of metal, it will allow electricity to move through it. So conductors allow electricity to move through it. All metals are very good conductors. Okay, so over here we saw this word conductor. The conductor is the inside of the wire where the electric current moves. But because we know electric current is moving, if we have to touch this, the electric current will move into our body and we can get shocked. It's not safe. So scientists know that some materials allow electric current to move through it, but there are other materials that do not allow electric current to move through. And these are insulators. Insulators do not let the electric current move through. They stop the flow of electric current. So for this reason, we put them on the outside of a wire. So good conductors are metals like steel, gold, copper, and silver. Water also allows electric current to move through it. Okay, but we will not make a circuit out of water. Okay, so you can focus on your metal. The insulator we will put on the outside here. We will cover the wire with it because we don't, the electricity will not go through it. So insulators are things like wood or rubber. Glass, plastic, and oil are also insulators, but they would not be a good choice to put on the outside of a wire. Okay, so now that we know what the circuit is made of, the parts of the circuit like the battery, the voltage source, our light, and our wire made of a conductor, we are now going to look at the two types of circuits we've learned about in our book. So over here we can see the way a simple circuit looks like in real life. And we can see that it's not very neat. The wires are kind of tangled. The light doesn't look as neat as it does over there. And if we had to draw this as a picture, not everyone is very good at drawing, and we may not be able to do a very good drawing of the circuit to show how it looks. So we've come up with symbols. So let's look at our two main kinds of circuits. Over here we have circuit A. Circuit A, we have added two lights next to each other, two resistors. So if you look at them, and it makes kind of like a circle shape, right? If everything is one after the other next to each other, it will make one loop. We call this a series circuit. If it makes one and two loops, then we call this a parallel circuit. So parallel has two L's, it will make two loops, okay? Series just will make one loop. So that's the main point you should look out for. You need to know the name of these circuits, okay? So please memorize the name series circuit and parallel circuit. Okay, next you need to be able to draw a circuit diagram. Like I said, this looks very messy. So we want to make it lovely and neat in our drawing, and so that everyone can be able to draw it. And how we do this is by using symbols. So this here, a long line and a short line, represents a battery, which is our voltage source. So you may see either word. Sometimes we have a key, sometimes there is no key. So you have to memorize this, okay? The long line and short line is our voltage source, which is the battery. Then we have our light. The light is a zigzag line like that, which means resistor. So our light, which is a resistor, is a zigzag line. And our wires are just straight lines. We like to keep our shapes lovely and box shapes. So we want lots of rectangles. We don't want it to look like wires and circles or any other shape, right? Straight lines. So this is our wire. Now let's see how we can take these symbols and use it to draw a circuit diagram. So a circuit diagram is when I use these symbols over here and I draw this using it. So everywhere I see a battery, I'm now going to put a long line and a short line. Wherever I see a wire, I will put straight lines. And where I see the bulb, I will put a zigzag here. So over here, sorry about that, we can see we have one zigzag shape, another zigzag shape. Okay, so now I'm going to connect it with the wire. And remember I said we like it to be a box shape. We want it to be nice and straight. And there is my circuit. So if I take the same picture and I move it over here, I have long line, short line. I have my box. I have one zigzag and I have another zigzag. And that's it. There is my circuit diagram of my series circuit. Okay, so another question they may ask you is if they give you the picture and they may label different pieces and ask you, what does this represent? They may name it X, Y, and Z, and you have to give it a name. So you have to know the light is X, the resistor. The Y is your wire. The Z is your battery. You have to know the names of the different parts, okay? Okay, so now that we know how to draw the circuit diagram for the series circuit, let's draw a circuit diagram for the parallel circuit. Just like we did for the previous one, the battery is a long line and a short line. If you think that you can do this, please pause the video and give it a try, and then unpause it and see if your solution is correct. Okay, so now remember our light is our zigzag shape. I have one zigzag here, one zigzag here. And then when I see how it's joined, I have one box over here. And I have another box going down at the bottom, right? So we can see the difference in the shape when it is in our circuit diagram, right? So as we draw our circuit diagram, we can see we have one zigzag. We have another zigzag. They are opposite each other. And because it makes two loops, I will join it with these box shapes. You will see two boxes when you are done. And this is how we know this one is parallel, because it has two of these. You see there's two sections with the zigzag. Okay, so this is how we can draw our circuit. Series, one loop. So you will only see one box. Parallel, two boxes. Okay? Please remember to use straight lines. I don't want to see any of those strange shapes. Okay? Don't make it look like that with the zigzag. It's wrong. Okay? Straight lines. Okay, so here are some examples of questions they may ask, but like I said, they could ask anything. So please review the material and make sure that you practice drawing the circuit diagrams, like cover the answer, try and draw them on a separate piece of paper and check and see if you are getting it right. Okay, just a quick note, you will see over here that they are not next to each other. They are next to each other, but one is here and one is on the other side. That's fine, okay? It doesn't matter if you put it here, as long as if I had to open this up, they are next to each other. It made only one box. Over here, they must be on two separate boxes, okay? Okay. Please scan the code and give this a practice. You may also join using that code. Thank you and good. Hi everyone, this is Ms. Zahra and we are reviewing for the end of term 2 science exam. So we spoke already about the structure of the exam. Today we will be looking at 3 multiple choice questions that may be asked about sound and light energy from lesson 2. Okay, so in this from this section from lesson 2, they will ask you one question about the picture on page 30 and 2 questions from page 32 about light energy. Okay, it's multiple choice only. So let's discuss what we know about sound. Okay, so sound travels in all directions. Okay, so sound starts over here. Over here we can see that the sound this is where it starts, the vibration that starts the sound. And we can see that it travels outward in all directions from the source. Okay, so that's the first point we need to know. The second point is that as it is traveling, we can see that there are some points where the particles are very close and other points where the particles are far from each other and they alternate. That means they in between each other, right? So the parts where they are pushing together, we say they are pressing each other. We call it a compression because it is pressing together, right? They're pushing each other with the p. The other one, they are far from each other. So we call it a rarefaction. Kind of looks like the word far, okay? So they are far from each other over here, and they are pressing, they are pushing each other over here. So compression are when they are close, rarefaction when they are far. So these are some possible questions you may get where they name this. You can name it any letter in the alphabet, but you have to know what they stand for. So remember we said when they are far from each other, it looks like the word rarefaction. Remember the word far will be in the middle. You have to look for, and it's missing the R, right? So far will be in the middle of the word, and it starts with a R. The other one, when they are close together, k, close, or p, pressing, is this section Y, or any letter they can call it, right? So here, where they are close to each other, we say compression. Okay, so please look carefully at your options in the exam and choose wisely. Okay, you may also get the picture instead of it being about this picture. It could be also about this image here. And if it is, maybe they might ask you, how do sound waves travel? They travel outward in all directions from the source. What kind of wave it is, maybe so longitudinal wave. Okay, so these are just some examples of questions you may get. Now let's talk about light. So light energy, light comes to us from the sun and it travels through space to Earth. The Earth's main source of light energy is the sun. That means the main place we get our energy from is the sun. Without the sun, we would not have food to eat. So we know that light can transfer energy. That means it can move energy and it can also change energy, right? So, how did it move the energy through space? We know it moved the energy through space because when we stand in the sun, our face becomes warm. So that means the light energy from the sun has come to us from space and it has transferred light and heat to make us warm. Plants have used this energy from the sun and they have taken the energy from the sun and they use it to make food. And we have uh, taken the food. Remember, we learned in the first lesson that food is chemical energy, and that's how we get our energy. So the first place the energy came from was the sun, and the food, the plant took it and made it into food, chemical energy. And right now we have our energy in our body because of the food that we ate. So scientists said we can do the same thing that plants do. We can take energy from the sun and use it to make electrical energy. So they do it using this device called a solar cell. Sometimes you may see the word photovoltaic. It's a very fancy word, but remember, photo means light in another language. So, a solar cell takes the energy from the sun and it changes it into electrical energy. Okay, so this device that changes light energy to electrical energy is called the solar cell. We put many of them together to make a solar panel. Now let's talk about how the light travels through space. So you can see here that light actually has two natures. It is both particles, small little pieces of things, and it is a wave. And it travels through space as particles. So because light has both of these natures, it can travel through space. Sound needs particles to travel through, so sound cannot move. But light is a particle, and that is why light can travel through space. So light is very quick when it moves through space. It's the fastest over there, and it has different speeds through different mediums. So light is quickest through space, and it gets slower when it moves through things like water, which is a liquid, and it gets even slower when it moves through things that are solids, like glass or diamond. So it's fastest through space, and then gas, then it slows down as it moves through liquids and solids. Okay, that's the main points we needed to know for light. Sorry about that. So please practice and good luck. Hi everyone, this is Miss Zahra, and today we will be reviewing for our final exam for term 2. Okay, so let's look at our structure of the exam paper. So remember, our exam is made up of 20 questions. 15 questions are multiple choice questions for 4 marks each. And our written questions, we call them free response, These questions are 5 questions, but they are worth 8 marks each. Okay, we will start by reviewing Lesson 1, Types of Energy. The pages that will be examined are page 12, 14, 15, and 23. Page 12 will be a written response question. So this one here, you will be required to write. Okay, so let's talk about our forms of energy. Remember that energy is the ability to do work. Okay, today we are going to look at a few different kinds of energies. Chemical energy, like the energy found inside of batteries and food. Nuclear energy, like the energy found inside of the sun and nuclear power plants. Okay, so these energies are stored energies. So stored energy is energy that is inside of something, and we can also call it potential energy. We learned about these energies in term 1. So the meaning of chemical and nuclear energy is almost the same. Both of these energies are stored between, they're stored in the links between particles. So we're going to say stored in the links. So the things that are joining particles together. Stored in links between particles that make up this part here. So you will learn this meaning for both of these words, but the last word is different. Chemical energy is found within in the links between particles that make up materials like wood, food, or batteries. And nuclear energy is found in the links between particles that make up matter. So the meaning of the words are almost the same. The only difference is for nuclear, we will say matter, and for chemical, we will use the word materials. Okay, when these links are broken, the energy is released. When the links are broken, the energy will come out. Okay, so this energy is stored energy. The next kind of energy we're going to look at are moving energies. The moving energies, we call them kinetic. So kinetic energy is moving. For example, your light energy. Okay, we know that light energy is energy that moves through matter and through empty space, and we can see it with our eyes. Okay, so it moves through matter and empty space. It can move through materials and it can move through empty space. Then we get electrical energy. This energy moves through wires. Light and electrical energy we will discuss more in another video. Okay, so thermal energy, thermal, ha for hot. And this energy moves from hot things to cold things. So just remember, thermal is hot. You will also maybe see the word heat sometimes, for example, from a fire, from a heater, anything that gets hot, a toaster. Over here you have a match, anything that lets the energy come out as heat, hot energy, we call it thermal energy. The last kind of energy we're going to look at is sound energy. Sound energy, it starts with a vibration and it moves through material. It cannot move in empty space, so it must move through matter, and it moves where? To our ears. And then we hear it as sound. So these are our 6 kinds of energy. Okay, we can group them as stored energy or energy of motion. Okay, these points are very important. We have already discussed them. You may pause this video and take a moment to read through it and try and remember. Okay, this is for our writing questions. So make sure that you know how to spell these words, how to make your own sentences using the words, and they may ask any question about it. But if you understood the concept of chemical and nuclear energy, then you will be able to write the answer. Okay, so now let's talk about energy transfer and energy transformation. So both of these words start almost the same way, trans and trans. But the one has for at the end and the one has formation. So this word form or formation means to make something new, to change. So to change to something new is formation. Transfer just means to move it, but it stays the same. So, for example, the energy when you kick a football is moving in your foot. So, moving energy from your foot is then transferred into the ball, which also starts to move. So, even though the energy has gone to something, a different object, it is the same energy moving and moving. So, we call this energy transfer. But if the energy becomes a new form of energy from the 6 that we have learned of, if it changes into something else, then we call it transformation. For example, when we use an electrical device, the device changes electrical energy into a different form of energy. In this example, thermal energy. Okay, so that's how we can summarize transfer and transformation. Let's look at some examples of how energy transforms, changes in this picture. Okay, so if we look over here at number 1, we can see that there's a window. And from the window, light energy is coming in. So we can see that energy it comes originally from the sun. Inside of the sun, we have nuclear energy, and it changes to light energy, which is then transferred into the room. Okay, so to the room. Okay, so from the sun. So the nuclear energy happens in the sun, and it transforms the energy into light. And that light energy then comes all the way through space into the room. Over here we have this teacher, and he is talking. The teacher is changing his chemical energy from his body into sound energy as he talks. Over here we have a computer. A computer uses electrical energy. So the energy from the electrical energy, is then changed into many different things. As we use a computer, we have light, it gets hot, so we have thermal energy, and it also makes sounds, so we have sound energy. Here at number 4, we can see these students here are building a model. So as they build their model, I'll write the answer here. As they build their model, inside of their bodies, they had chemical energy from the food they ate, and that energy then is transformed or changed into moving energy as they move their hands to build the model. Okay, on page 23 of your book are 3 questions. You must learn these. So let's look at what they mean to understand the answer. The first question says, which best describes how energy changes in a toaster? A toaster is this device. We can see that the toaster uses electrical energy, and we also know that it makes something hot. So we know we are looking for a word electrical, and we want to find the end being thermal. So we look at our options and we can see that that is option C. In the second question, it says a radio sitting on a table made water move. What can we conclude? If the radio made the water move, that means the energy is transferred from the radio into the water. The energy there is moved from the radio into the water. So these vibrations will move. Okay, and the last question, you had to fill in what happened over here. So remember, they could change any of these. The main thing is to understand your types of energy. Here they say the word motion, which we know is something moving or kinetic. Sorry, I spelled that wrong. Moving, right? So something that is moving to a sound energy. So if we look at these examples, burning is thermal energy. So burning a candle, that would be chemical, becoming thermal. Here we have plucked guitar. That is when you move the string and it makes a noise. A noise is a sound. Here we have the ball roll down a hill. So we had potential energy in a ball that went down the hill and it became moving energy. Here we have rubbing warm hands. That is moving to warm thermal. Okay, so only 2 options involve moving, B and D. But we must also look for the end being sound. Here we have thermal, sound, kinetic, thermal. The only option that gives us sound is B. And that is why we chose this as the answer. Hey, now it's time for you to practice. Please scan the link or you can join using the code over here and give these questions a try. Good luck.